So now you can study, it would be easy to you guys. Okay, what is packet filtering firewall? Packet filtering firewall monitor the data packets based on the layer 3 and the layer 4 of the OSI model, right? It check the header. It check the header. So header of the each packet. What is header? What is payload? What is IP header? What is IP header? What is Ethernet header? These are important terms. If you want to become the security engineer, right? The good security engineer. So you should know about what is Ethernet header, like what is IP header, right? And what is TCP IP. So Ethernet header is going to be added on the layer 2, and the IP header is going
added on the layer 3.
And TCP IP header is going to be added on the layer 4. Clear? So this we need to be clear. Then only we will be in a good position to understand what exactly the filtering is happening. Clear? And bol Zamil.
Layer 2 header also
Ethernet header.
अब layer 3 का router का नहीं ऐड होता. अभी layer 4 का कैसा होगा?
Layer 4 भी router का नहीं ऐड होता. उसे बोलते हैं TCP IP header बोलते हैं. TCP IP header. Let me explain you. TCP IP header बहुत बड़ा concept मुझे मिल अच्छा बोलता हूँ. We have a OSI model, right? We have 7 layers, correct?
Okay.
The first layer is physical layer. On top of that, we have a data link layer. On top of that, we have a network layer. And on top of that, we have a transport layer. Above 3 layers are called as a software layers, right? These layers are the hardware layers, like physical layer, data link layer, network layer. So if you have a packet, consider your user is connected towards a switch, right? If the user generated some traffic, right? The traffic is going from user to the switch with the help of physical layer, right? With the help of physical layer is jata hai na? Like, so now data packets has reached us to switch. So what switch is going to do? So that frame, actually in data link layer we used to call as a frame, right? This is your data frame, actually frame. Here we have a payload. So on top of that, it is going to add the Ethernet header, ETH header. Okay. So once that packet go to the network layer, okay, there that is going to be the frame is going to be changed as a packet, which is nothing but your actual payload, and there it is going to add the IP header, header. So here you will be identify what is the source and destination. Then it has to be identify the protocol also, right? Whether it is a TCP protocol and the UDP protocol, what is the source port number, what is the destination port number. So it will go to here, transport layer. Once it go to the transport layer, right? So again, that is going to be happen. What here we will have a segmentation, sequencing, reassembling. It is going to happen a lot of stuff, but I'll write as a data packet or else payload. Data or payload. For that packet, it is going to be add as a IP header, TCP IP header. Clear? So user is going to generate a packet. So once that packet is going to be reach the switch, okay, so that frame is going to be added with the Ethernet header. So once that was like reaches to the network layer or layer 3 device, that is going to be added as a IP header. Then once it reaches to back to the transport layer, there it is going to add a TCP IP header. We'll have a detailed class, at least Muzammil, to explain TCP IP, like TCP IP, to explain TCP IP header. I required minimum 2 hours, bro. Minimum 2 hours, because see the TCP IP header. Let me explain you in overview. The TCP IP, okay, the TCP IP header is having 11 fields. Will have 11 fields. On that 11 fields, okay, so there is one important field that is nothing but control flags. Control flags. In control flags, we have a SYN SYN flag, okay, acknowledgement flag. Even we have a FIN flag, which means finish flag, and RST flag, reset flag, okay, and URG flag, which is urgent flag, and we have one more flag, I think so. SYN plus ACK and FIN reset urgent finish. We have one more flag, okay. So I require minimum 2 hours to explain. Actually, we have a different 11 fields. In the 11 fields, we have a source port, destination port, sequence number, acknowledgement number, and data offer ports, and reserve ports, control flags, windowing, open queue. So there are 11 fields actually. So it is a different concept, Muzammil, when we are going there, right? So we are going to explain.
Okay.
Yeah. Maybe yeah.
Hello, one doubt, Anna.
Yeah, yes.
Anna, show previous image, Anna, once. We can see that this Ethernet header in network layer or not, Anna. Here you are not.
No. In data link layer, you can see.
Okay.
Layer 2. Okay. In network layer, you are seeing IP header. If you capture the packet set, you can see that. In transport layer, okay, that is going to change as a TCP IP header. This is what it is like. So it will require around 1.5 hours to 2 hours to explain in detail what exactly happened. See, generally, let me tell you one more thing. So generally in this slide, where it is? Generally in this slide, right? So I'm saying you this is a source and this is a destination, right? So if you want to access this website, first what this user is going to send, like it is going to send a SYN packet, right? Synchronization packet. Then return packet will come as a synchronization plus acknowledgement. Then it will have an acknowledgement packet. Then have a server hello, client hello. Then the actual payload, the actual data is going to be transferred. But in CCNA level, what we used to study, right? What is TCP? TCP three-way handshake means synchronization packet and synchronization plus acknowledgement packet and acknowledgement packet, right? But exactly if you jump into the firewall kind of concept, if you jump exactly the TCP IP header, so there we have 11 fields. Okay, among that 11, out of this 11 field, we have a control field which is very important. Control flags. In control flags, we have 5 flags. Based on that flags, whether the server is terminating the connection or the client is terminating the connection, or else it was happened the reset, the connection was reset, the connection was finished, each and everything we can see. That is what the visibility is going to provide the firewall. But router, you will not see those things. So you need to be capture the packets on the router. So what packets are going, like traversing, what packets are traversing between the router, this edge device and the particular server. So you need to capture the packets here. Then only you can see that in the Wireshark. That is different stuff. We'll discuss about that. Okay. Okay, Sai?
Okay, sir.
So hope the packet filtering firewall was clear. So the packet filtering firewall is simple. It is going to be filter the traffic based on the source IP, destination IP, protocol, and the action, right? And it is going to be like filter the traffic based on the ACL, access control list, that we are going to configure on the router, iOS device, inter-operating system device. So nothing but, it is going to provide the low kind of security, low level of security. It's not a high level of security, because we have the like the router may get IP snooping attack, right? So that's why earlier we have before firewalls. Okay, these guys are going to be work as a packet filtering firewall. Now, what is stateless firewall? This is very important, guys. Even in every interview, they are going to ask you the difference. What is the stateful? What is the difference between stateful firewall and the stateless firewall? So, the stateless firewall. So, in general, if you ask me, right, what is stateless? The stateless is nothing but it is not going to like it is not going to make the connection. It is not going to make a note the connection in the session table. It is not going to maintain the session table actually. It only filter the traffic. It only send the traffic, like whatever it comes, it will send. See here, there is some drawbacks as well. Let me explain you. Okay, the stateful firewall, the stateless firewall. Stateless firewall is a firewall that filters the packet, okay, without keeping a track, which means it is not going to maintain the session table. In stateless firewall, it is not going to maintain the session table. So it's not going to make the track of the state of the connection. So whether the connection is still open, connected, still established, still the connection is running, or it is not running. So that we are not going to get in the stateless firewall. It makes the decision based on the each packet header. So everything, it is going to check the packet header, not on the part of the existing session, whether if we have the legitimate existing session or not. Okay, if you have the legitimate existing session, that is only the firewall, which firewall, stateful firewall is going to maintain the legitimate session, but the stateless firewall is not going to maintain the session. What is the drawback here? Actually, the next generation firewall, how it is going to be work? The next generation firewalls are going to be work like if you consider this is our next generation firewall which we place here. If it is working as a stateless firewall, so the connection will go from here to there, like it went. So whether this firewall don't know whether the same packet is coming back or not. However, it is going to be allow you. So that is what the drawback. Even the network engineer or the security engineer need to configure the two policies, in to out and out to in. Two policies need to be configured in the stateless firewall. That is what I mentioned in the slide. If you read this slide right carefully, stateless firewall is a firewall that filters the packet, okay, without keeping a track of the state of a network connection. It is not going to track the session, whether the session is open or closed. It makes decision based on the packet header, each packet header, not on the whether it's a part of an existing. If it is an existing connection also, still it is going to make the new connection. Required two-way rules. Actually, in router we used to call it as ACL. ACL, hey, did you configure the ACL to allow the traffic, like that we asked, right? But in the firewalls, we are going to say the same term. We are going to tell the same term. It's a rule, security rule. Some guys will say like the security rule, or some guys will used to say the ACL rule, or some guys are going to say like a security policy. All are same, guys. Security rules, ACL rule, or security policies. Everything is same. So if you are going to deploy, like if you are going to use the stateless firewall, then you need to be configured the two-way rules to allow users from your LAN to internet and internet to from outside request to the separate connection for the incoming, which means incoming to outgoing and outgoing to incoming. You need to configure the two rules. And this is going to inspect again the source IP, destination IP, source port, destination port, protocol, and the direction. Direction means which is inbound direction or outbound direction. Even we are going to define in some, like once you configure the ACL, right? So that ACL is going to be defined on the particular interface, right? If you are going to define here, what would be the direction? If the traffic is going like this is the inbound direction. If you are going to define here, it would be outside. So the direction. This is your stateless firewall. And this is not going to be used on the production networks much more. Because the stateless, if you don't maintain the connection, right? If you don't maintain the connection, then it is going to be like very problem in the production networks. So all the next generation firewalls are going to support a stateful inspection. This is very important term. What will happen in the stateful inspection means it is going to make the connection stable, which means state table. Stateful firewall maintain the state of the connection, in the stateful table. So next generation firewalls are going to maintain the state table on the firewall. When packet is traveling from source to destination. After adding the information to the state table, it is forwarding towards the destination. So first, for example, if the packet is received to this firewall, first it is going to check whether the stateful inspection, which means it is going to be add that packet to the state table. I told you, right? Session table or connection table. It is going to add that packet to the state table or the connection table. Then it is going to send that destination towards the destination. when the packet is coming back from the destination towards the firewall is again going to check whether this packet is the previous packet which I sent or not. If it is matching the same thing, for example, this user is trying to access this particular YouTube server like this. Okay, this is our SYN packet. Like first packet will be SYN, then the second packet will come the SYN plus ACK. When it is sending the SYN packet, the firewall is going to add in the state table, right? So okay, one SYN packet has went towards me. So if the return packet is coming from SYN plus ACK, so when it is SYN plus ACK is coming, right, firewall is going to match, okay, whether the same packet, this is a SYN plus SYN ACK, then only it is going to be allowed towards the inside network. If it is not matched, firewall is going to be drop that packet. That's what the stateful inspection. For every connection, it is going to maintain the state table. See here, stateful firewall maintain the state table, like state of connection or in the state table of the firewall. When packet is traveling from source to destination, after adding the information to the state table, it will forward to the packet to that particular destination. Then the receives the reply, which means the reply packet. If it matches the packet information to the state table, okay, if the firewall receives the, if it is match the reply to the packet, then only it is going to be allowed towards the inside. If it is not matched, the reply packet is not matched, right? It is, otherwise it is dropping. If it is matched, then only it is going to be accept. If it is not matched, it is going to be drop. Simple role management, only one way direction needs to be configured. This is what the difference, guys. The stateful and the stateless. If the stateless inspection is happening in the firewall, then we need to configure the inside to outside rule and outside to inside rule. If your firewall is doing a stateful inspection, you just need to configure a single rule. Okay, you just need to configure a single rule. Okay, once the return packet is hitting to this particular firewall, that firewall is going to be maintain the session table, right? It is going to be verified with the existing session, whether it is the same connection or not. If it is the same connection, then only it is going to be accept that connection, allow towards inside, or else it is going to be drop that connection. Clear? And the next firewall is the next generation firewall. So this is very important. We have two more, just bear with me. Okay. So the next generation firewall is nothing but the same thing, whichever we like. Palo Alto is your next generation firewall. If you use the Cisco ASA, it is the legacy firewall. And if you are using the the router ACL on the zone-based firewall or the packet filtering firewall, those are the legacy firewalls. So those are not in the production nowadays, but still we should know about what exactly they are going to do. So the next generation firewall is, it will add the traditional firewall. Okay, next generation firewall perform the role of traditional firewall as well as the next generation IPS, which means next generation intrusion prevention system. It's a part of third generation. It's a part of third generation. So the next generation firewall is your part of the old firewall, which means the legacy firewall and the traditional firewalls and the next generation IPS features. All next generation firewalls offer the features application layer filter. Application layer filter. In the packet filtering firewall, in the other firewall, stateless firewall, we don't have this feature like application filter, deep packet inspection, and intrusion prevention system. This you guys are going to be understand more when you know future classes, but as of now, just remember that the next generation firewalls are going to be support for like the application layer filtering and the deep packet inspection and intrusion prevention system. Why it is required? To inspect the traffic with high performance. It is going to be inspect the packet, not only the application. If it is the YouTube, okay, just YouTube. It is not going to inspect just YouTube. Inside the YouTube, what exactly we have the content? What content is going in the YouTube? Because nowadays you can see, right, even the illegitimate websites, they are going to come with the HTTPS. Even though the website is a bad website, that is going to come with the HTTPS. Okay, if it is a legacy firewall, okay, it will see that okay, there is a HTTPS, which is nothing but it is a secure. So the firewall is going to be allowed. But the next generation firewall is going to be check your content as well. What content? Even especially in Palo Alto, there is a feature like app ID, application ID, content ID, okay, content ID and user ID. With the help of this feature, the Palo Alto firewall is going to inspect deep level inspection. Okay. So the next generation firewall allows and block based on the specific application as well as based on the user information. Okay. So earlier what we do, right? We configure the ACL. So when you configure the ACL, that is going to filter the traffic based on the source IP and the destination IP address. Source IP address and destination IP address. But in the next generation firewalls, we have the feature that we can filter the traffic based on the user ID as well. Based on the user ID. That's what I mentioned here. Next generation firewalls allows or block the traffic based on the specific application as well and based on the user information as well. With the help of user ID, it is going to be inspect that okay, which user is trying to be accessed. There is no much difference between the UTM, okay, UTM firewall and the next generation firewall. Do you guys like heard about the what is UTM?
No, sir.
It is nothing but unified threat management. Okay. After that second generation firewall, so even UTM firewall will also have the same kind of feature like the proxy, proxy IDs, app ID, application filter, like URL filtering. This feature even UTM filter, UTM firewall also have those features. But the thing is, UTM firewall, UTM is going to be used in the like the medium kind of organization, but the next generation firewalls are going to be used in the data centers, DCs. UTM firewalls are, you can see in the branch offices, right? In the branch offices and the like medium kind of network segments. But the next generation firewalls always you will see in the, so if you want more security, then you need to go with the next generation firewalls. Next generation firewalls are like perform high performance and processing using to protect. It is going to be it is going to give the high performance and the high throughput actually compared to the UTM. Here, why I'm giving more stress on the next generation firewall means, let me take one more slide so that I can explain you. Actually, next generation firewall is very important. If you have a firewall, consider this is your PA firewall, Palo Alto firewall. So generally in the Cisco, we are going to configure this is my inside, this is my outside, right? And this interface used to call as an ingress interface, and this interface is egress interface. Ingress interface, egress interface. Okay. So inside interface, outside interface. Now here, consider here your PC. That guy is sending some data. Okay. That data along with the IP header. Once it is reached to the firewall, right? Ingress interface. This firewall is going to perform the inspection. This firewall is going to perform the inspection. In this inspection, what is exactly going to be performed? So in the inspection, so it looks like source IP. What is a source IP address? And what is a source port? And then destination IP address, destination port number. Now here we have the good thing, which is layer 4 inspection. And in layer 4 inspection, I told you right in the last slide, where it is here, I think in the layer 4, which means where it is going to be happen in the layer 4 inspection. Layer 4 inspection is going to happen in the transport layer, right? Transport layer. In this transport layer, we have one field. I told you that this is the important field, control flags. Under control flags, these are all the flags, right? So there it is going to be used. What is a flag? Even the flags also it is going to be used. Flags. And then sequence number, then acknowledgement. This is what the advantage, guys. This is what the advantage. This is the state table actually. This is the your stateful table or state table. See now, if the user is trying to access any websites or the web server over the internet, okay, once it was hit here, the ingress interface, it is going to note down all the like the session. So what is the source IP? What is the IP of this guy? And what is the source port? On which source port number the connection was initiated, for what exactly the destination IP address and the destination port number. Here in the layer 4 inspection, it is going to add whether it is a TCP or UDP based service. In the flags, it is going to be add whether it is a SYN packet or SYN plus acknowledgement packet, what packet it is. And the sequence number of the packet also it is going to be add and the acknowledgement packet. Okay, so as of now we don't have acknowledgement because this packet is going to be initiated from LAN user, as it is a first packet means it is a SYN packet. This is what your state table. So this packet is going to be add here, then it is going to be forward the data to the actual destination. When the data is replied back, once it received to this particular interface, this is going to again the state table and it is going to match. Okay, this is my source IP address, source port, destination port, right? So this time this will become the source. While the data is coming from destination, so this will become the source. And this portions will be changed, source port, destination and the destination IP. The remaining is same. So earlier it is a TCP and it is a TCP. When it is going from LAN side to inside to outside, it is a SYN packet, right? When it is coming from out to in, it should be a SYN plus acknowledgement. Then only this is going to be allow that connection to the inside, or else it is going to be dropped. Consider it is again SYN, then it is going to be dropped because the session, whatever the session is coming from the outside, it is not going to be matched to the state table. Clear? Any confusion here? Guys, any confusion? Sai?
No confusion.
Yeah, right.
Yeah, clear.
Chalo. The next topic. So if you study now, it would be very easy. Okay, what is next generation firewall means? Next generation firewall performs the role of a traditional firewall as well as this one, the next generation IPS, intrusion prevention system. So it is going to do the stateful inspection, right? Whenever it is going to the stateful inspection, it is going to add the connection to the state table and it is going to perform whether it is application filtering, deep packet inspection and intrusion prevention system. Now we have the proxy firewall. What is proxy firewall? We have two more firewalls. Okay. So what is proxy firewall means? Act as an intermediate between an internal network and the external network to prevent the direct connection. Okay. So consider. Let me go through the first points, then I'll draw the topology so that you will understand. Proxy firewall means it is an intermediate between inside network and the external or outside network. Because to prevent a direct connection, this adds a security but can introduce the latency. Why it is latency, we'll discuss why the latency will come. And the proxy firewall works as a proxy for client, for LAN users. No direct connections occur between the client and the destination server. And the proxy firewall takes request from the client, put that request on hold for a moment or some time on behalf of client. That particular proxy server or the proxy firewall is going to initiate a new request to the particular destination. So we studied about the points, right? We just gone through the points. Let me explain you in the architecture. See what will happen, right? This is my firewall, which is proxy firewall. I place in between. Here I have a user which is connected here. Here I have a web server over the internet. We have a connectivity towards internet. See what proxy firewall is going to do. It is not going to like make a connection, direct connection to that particular web server. It is going to terminate that connection because so whenever this user wants to access this particular web server, right, the request will go to the proxy server. On behalf of this client, this proxy server is going to be generate one more request because this proxy server wants to be had his LAN user. So here client to this proxy server connection 1, right? Let me take other pen. So connection will come to here. This is connection 1. And this guy is going to make another connection on behalf of this client. This is our connection 2. And this guy is going to be reply, right, to this proxy server, connection 3. And this guy finally is going to be give that output to that particular end user, which is connection 4. So here see, the connection is coming, then it is on behalf of user, proxy server is going to be initiate the connection. Then again the reply packet is coming to the proxy server. That proxy server is again going to share the output to that actual end user. So here the latency is there. It is going to add the security because it is not going to like this user, it is going to this particular proxy server is going to be protect this particular user identity, but still there is some latency. Latency is happening because due to this connections, client to server, server to client, server to server, then server to server, server to client. So this is why this is not like much famous in the industry. You can see here. That's why I mentioned here the points are proxy firewalls are intermediate between the internal network or internal user to the external. It prevents the direct connection. It prevents the direct connection, which means it is not going to make the direct connection. It adds the security. It is going to add the security, but there is a latency, right? So it takes the request from the client, put that client request on hold, and on behalf of the client, the proxy server is going to be initiate the request out to the final destination server. So that is what your proxy server. So now final one, we have the web application firewall. One second, guys. Yeah. What is web application firewall? A web application firewall is a specialized firewall, especially designed to protect the application layer, to protect the web application or the application layer kind of things. See here, web application by filtering the monitoring or blocking HTTP and HTTPS. So HTTP or HTTPS that you are going to see in the application layer only, right? So the web application, the web firewall or the WAF, the main intention of the WAF is to protect the application layer traffic. That is going to be a traffic between a client, usually a server, and the web browser. Which means user is having here the laptop. So he is having some this one, right? Browsers. With the help of that browser, he is trying to access any of the websites. So when he is trying to access the website, that website we can control here, like with the help of web application firewall. It protects against the common website exploit and vulnerabilities such as SQL injection, cross-site scripting, and cross-site request, file inclusion attacks, and the HTTPS violation. So this WAF is generally you will see, right? So if you have a clients, like multiple clients on even the end user, see generally the best example for this WAF, right? You can use the Kaspersky antivirus solution, right? Antivirus solution that is going to be suited for this. So with the help of, even if you build the servers, right? If you build the servers, every server, even though you have a physical firewall or hardware appliance in your network infrastructure, again you are going to be install a client which is nothing but WAF on the server. So this is about the firewall and the history of the firewalls. Okay, so what firewall is, how the firewall is going to be work, what is a difference between packet filtering firewall, stateful firewall, and the stateless firewall, next generation firewalls, and the proxy based firewalls, and the WAF. So if you clear with this terminologies, right, in every security interview, guys, in every security interview, you are going to be get the question from this. if you don't, if might not get for like the what is WAF firewall or the proxy firewall, but you will definitely get the question from what is the difference between stateful and stateless firewall. This is very important question. What is the difference between stateful and stateless firewall, and what is exactly the firewall and where you are going to be use the firewalls?